Greetings everyone, my name is KAUSHALYA A and I'm a computer science final year undergraduate from USM, University Science Malaysia, and today I'll be presenting on my research project titled Designing Personalized Learning Paths for Coding. So, my presentation outline is as such. I would cover a brief research background followed by the research problem statements and objectives. Then, I would cover the research methodology and implementation as well as the results and evaluation section. Finally, the presentation is to be concluded with a brief summary. Let me begin with my research background. My research emphasized on block-based coding for children in terms of how to monitor and evaluate a child's progress effectively. First of all, why is it important for children knowing how to code? So, it's important for children learning to code because it builds their computational thinking skills and makes them more creative and think authentically. So, there are a few block-based coding platforms out there such as Scratch Programming Interface as well as the MIT App Inventor. And it is easy to learn for children even without a programming background. So, why is block-based coding more effective in the terms of coding for children? This is because block-based code, it helps to visualize the logic behind coding. Next, how to make the individual learning process more effective, especially for child beginners who are just starting to learn how to code. So, personalized learning through intelligent tutoring systems comes in. So, currently, there are a lot of work in intelligent tutoring systems, and most intelligent tutoring systems have implemented a concept called as knowledge space theory or KST, which is used very commonly in building ITS. And how does KST work, or how does knowledge space theory works? So knowledge space theory, it helps identify the knowledge states of a student and model learning materials accordingly. So as I said previously, there are various existing ITS or intelligent tutoring systems. However, most of the ITS are developed for syntax-based coding, means for programming languages such as Java, HTML, CSS, and more. So a few ITS of block-based coding evaluate students' answer using static code approach. However, this approach only checks for similarity of student code with one sample solution or model solution. So if there are other possible solutions to a problem, this approach fails and scoring accuracy is reduced. And besides that, most ITS have the complex concepts implemented in their learning process and catering to the needs of older students or university students. So this may not be suitable for children who are learning to code, and this is something that should be considered. So now I would like to discuss on the problem statements. So there are 3 problem statements which I have considered in my research. The first one is that fixed learning assumes all children learn with the same pace and capability. The second problem statement is that the lack of methods to monitor and evaluate a child's progress in block-based coding. And the third problem statement is definition of complex concepts in intelligent tutoring systems for block-based coding. Now, there are 3 research objectives. The first one is to define basic knowledge states in coding for children. The second one is to identify suitable evaluation methods to track children's progress in learning coding. And the third research objective is to explore different learning paths tailored based on a child's learning capability. Now, I would like to discuss on my research methodology and implementation. My research methodology is divided into 5 main phases. So, the first phase is to develop a knowledge graph. So, what is a knowledge graph? Knowledge graph is a mapping of a few concepts which is used to learn how students progress according to certain learning materials. So in order to develop this knowledge graph, knowledge space theory has been implemented in this study, and syllabus analysis has also been implemented to derive knowledge states. So how the syllabus analysis is carried out? A few relevant sources such as textbooks as well as the Scratch websites have been studied, have been researched thoroughly in order to derive suitable knowledge states for the children in the age of 10 to 12. And the next phase towards this research methodology is to develop the set of coding challenges. So there are 9 coding concepts which are to be implemented in my study. So for each of these concepts, there are 5 challenges designed together with and reviewed by domain experts. So looking into the third phase is to develop a learning application. So this study focuses on personalized learning as the test group and also the fixed learning as the control group. So in order to evaluate the student learning progress accordingly, 2 sets of applications were designed, which is the personalized learning application or PLA and fixed learning application, which is PFLA, with the different set of logic behind the application. So for PLA, they are required to put the name as well. Okay, once they have put in the names, they are able to watch a short tutorial video in order to understand the concept, and once they are done, they are able to attempt the challenges accordingly. So they have to read through the instructions and they can put together the blocks. There is a drag and drop interface implemented together with this application. So once they are done, I'll be manually assessing their scores in terms of the order of the blocks, the number of the blocks, as well as the type of the blocks used. So if let's say they fail, they did not fulfill the requirements, then they are able to repeat the same concept again with another challenge. So how does this works? If they want, they can watch the video again, and they are able to repeat the same concept, but this time with the second attempt, with the second challenge, which is similar to the first one. So if let's say they have passed, then they are manually redirected to the second concept as such. So the same thing, they're able to watch the video and then they're able to attempt the challenges accordingly. So for each of this set of coding concept, there is a maximum of 5 attempts. So they're able to move on to each of these concepts accordingly. Looking into the fixed learning, it's a similar example, it's a similar application as well. So they have to put in their names as well as email. And then they're able to watch the tutorial video and they are able to attempt the coding challenge. So how does this work is that they are able to put the blocks together, and once they're done, they're manually assessed. So if let's say they have passed or they have failed, they are still able to move on to the next concept. So they're not able to repeat like how the personalized learning application has the capability to do so. So the next phase in my research methodology is the fourth phase, which is to conduct the learning path experiment. Firstly, 24 school children, primary school children were recruited in the age category of 10 to 12 years old. Then they were required to do an entry test in order to categorize themselves as good, average or weak competency groups. So the entry test is designed in such a way that it has 15 multiple choice questions, and this purpose of the entry test is to test their preliminary coding skills. After they have performed the entry test, these children are distributed equally of 12 and 12 into the test and control group. The test group is the children who are undergoing personalized learning path, and the control group are the children who are undergoing a fixed learning path. So this learning path experiment is conducted online via Zoom video conferencing platform, and children are given the remote access to the application throughout the session. So firstly, when they are able to come inside the application to do the experiment, they are able to watch the tutorials for each of this concept and try the coding challenge accordingly. So once they have done, they are manually evaluated on the spot to see if they pass or fail in a concept according to a scoring rubric which was designed together with an expert. So once they have done with the experiment using the learning application, they are to do the exit test, which is also similar as the entry test with 15 multiple choice questions. And the purpose of carrying out exit test is to evaluate the post learning path experiment coding skill. So the fifth phase is to identify learning paths for children to code. So this learning path is applicable for the test group, which is the unique with a unique learning path as they undergo a personalized learning. So the learning paths is indicated by length, competency, as well as duration of the learning paths of children. So now I'd like to discuss on the results and evaluation. So these results and evaluation are further distributed into 4 key findings. The first one is unique learning paths. The second one is competency of coding concepts. The third is duration of learning paths. And the fourth one is coding performance improvement. So looking into the section of unique learning paths, which is applicable to the test group or the personalized learning path children, as we can see, there are 3 competency groups, which is good, average, and weak. So the mean length of learning path is calculated as such, in which the number of attempts for a coding concept is total up together with all the students in that competency group and divided by 4. Why 4? Because each of this group of competency has 4 children distributed equally. So as you can see, the good children and average children are performing on par, and the weak competency group children have the longest mean length of learning path. So what does this indicate is that the weak group of children needs more attempts to pass a coding concept and to maximize their learning performance before moving on to the next concept. So now, looking into the competency of coding concepts, competency is indicated by the overall score for each of these concepts. So this is applicable to both test group and control group. So looking into the personalized learning group, all the competency groups of good, average, and weak children are performing equally. So as you can see, the deviations are less for the mean overall average score. And for the fixed group or for the control group, there are slight deviations among good, average, and weak children. As you can see, the mean overall average score is 95.34 for the good students, 87.17 for average, and 87.13 for the weak students. Why is this happening is that because for the personalized learning path, each of the children are able to learn one of the concept effectively, even if they are allowed to repeat, even if it takes time, but this maximizes their learning process. So they make sure that their concept is strengthened before they are moving on to the next concept. But for fixed learning, however, it's not the same. So once they are entitled for only one time of concept attempt, and if let's say they fail, they are still able to move on to the next concept regardless of their strengthened understanding on the previous concept. So if let's say the second concepts need the strong understanding and integration of the first concept, this may be a disadvantage to the children because they can't integrate the previously learned concept as they didn't pass the concept. So this is why personalized learning is important for children in learning to code. Looking into the duration of learning paths, there are 3 competency groups as well tested, and this duration of learning paths is recorded only for the personalized learning paths. So how is the mean total duration calculated? The total time for a child to attempt the coding concept is summed up divided by 4. So as you can see here, the good children has the shortest duration of learning path compared to the rest 2 competency group. So what does this indicate is that the higher the competency level of a children, means such as good children, the total duration of the learning path will be shorter because they take less time to comprehend their knowledge and attempt on the coding challenges accordingly. Now, I would like to discuss on the coding performance improvement. So, as you can see, we have the 2 large groups, which is the control group and test group. So, looking into the mean entry test score and mean exit test score, both groups have performed equally well from the entry test to the exit test as the improvements were observed. To conclude the presentation, the higher a child's competency level in coding, the shorter the length of his or her learning path. The second one is the higher a child's competency level in coding, the shorter the duration to solve a coding challenge. And children undergoing a personalized learning path has a better learning performance compared to children undergoing a fixed learning path. So, looking into the future work of this research, the knowledge graph which was derived previously could be used to design learning modules for children learning to code. And currently, the automated scoring module is developed separately using Python fuzzy-wuzzy matching in order to substitute the manual scoring and to be integrated to the learning application. So, that's all for the presentation. Thank you for watching.